Hey guys, so we have a lot to cover in our video today. I'm going to try to get all this content in before we go on spring break because I want to give you a quiz later this week. So pay close attention to everything that's going on in this video. If you keep your notes, you can use them on the quiz. So first of all, we're talking about relationships between two sets of data that are proportional versus non-proportional, and how to spot the proportional ones when you're looking at the data in different ways. So first of all, if two quantities are proportional, then they have a constant ratio. That means that you're looking for equivalent ratios. You guys know how to do this. If you keep seeing that equivalent ratio and multiplication to get from one number to the other on the variable, that means you have that constant ratio. That means you are seeing something that is proportional. If the ratio is not constant, the two quantities, the two sets of numbers, are said to be non-proportional. So you only get that proportional relationship if you have equivalent ratios. This is when we're talking about a graph. Proportional relationships will always go through the origin on a graph. That means that they will always go through that 0, 0 point, and they will always be a straight line. If you see a graph and it asks you if this relationship is proportional, if it is a straight line and it goes through the origin, the answer is yes. Okay? We always write the constant ratio in the form of y over x. And basically, the simplified equivalent ratio is the constant ratio. So when you've got like 15 to the 5th and 3 to the 1st, okay, that the 3 to the 3 over 1 is your constant ratio. That's your simplified equivalent ratio. Okay, so in order to tell from a table if there's a proportional relationship or not, you can check to see if the ratio, x over y, is the same. Again, look for these equivalent ratios, okay? This is super easy. Just look for the equivalent ratios. Don't let little silly mistakes trip you up. The constant ratio y over x is also known as the scale factor. I don't think you need to know that for your quiz, but you might need to know it for your benchmark test. Okay, so let's start talking about whether or not these are equivalent ratios. Write down everything I'm writing down here. So if we put in this first box the y over x, we are putting 10 over 5. If we reduce that, that is 2 over 1. 16 over 8 is 2 over 1. 20 over 10 is 2 over 1. 28 over 14, divide both of those by 14, 2 over 1. 42 over 12, divide those by 12. I'm sorry, not 12. 21. Let's do this. Sorry, my bad. I'm trying to go too fast so you guys can get time to work. Divide both of those by 21. 2 over 1. Is it proportional? Do we have a constant ratio when we simplify everything? Yes. Write it down. What is our ratio? This should be pretty obvious by now. 2 over 1, or 2 firsts. Our equation, so we're going to talk a little bit more later in this video about writing equations, but basically, what do you have to do to the x to get the y? So to get our y, we take x times what? X times 2 or 2x. So whatever you put in for x, we'll put in for y. Don't worry about this ordered pair. All right, over here, let's write our proportional relationships. Let's see if this is a proportional graph. 2 over 0, we can't simplify that. 8 over 3, that can't be simplified. 12 over 5, again, can't be simplified down any farther. 20 over 9, nope, that is a 9. 22 over 10 can be simplified to 11 over 5. Is this proportional? Are we getting the same ratio like we did with this one? The answer is, of course, no. There is no ratio. The equation, if you want to look at this, so what do we do to the x to get the y? So to get our y, we take x, what? Times 2, or 2x plus 2. So you see, 0 times 2 is 0, plus 2, 2. 3 times 2 is 6, plus 2 is 8. 5 times 2 is 10, plus 2 is 12. 9 times 2 is 18, plus 2 is 20. 10 times 2 is 20, plus 2 is 22. And I said we don't need to worry about this. So this is an example of a not proportional, and this one is proportional. All right, so in order to tell if a graph is proportional, you need a straight line that goes through the origin. Again, not hard. So this is our origin here. I'll change my color of my pen to magenta. All right, so this is our origin. It's where the x and the y-axis intersect. Does this one go through the origin? Check. Does this one go through the origin? Nope. Is this one a straight line? Yes. Is this one a straight line? Yes. But this cannot be proportional because it does not go through the origin. It's missing that key component. So yes, actually I think that might be, okay. And then this one is a big fat no. And why? The line goes through the origin. The line does not go through the origin. All right, so let's graph an example here and see for ourselves. Now, if you guys are crazy, stupid, smart, like I know some of you are, you can just look at these variables, think about the relationship between the x value and the y value, and you can figure out for yourself if this is a proportional relationship. If you look at the relationship between 8 and 4, 10 and 5, 5 and 2.5, and 12 and 6. But for some of us who aren't crazy, stupid, smart like you guys, we're going to go ahead and graph it and see if we get a straight line that goes to the origin. So let's start with 8 as our x value and 4 as our y value. Plot that point. 10 as our x, 5 as our y, 5 as our x, 2.5, which is right in here between the 2 and the 3, is the y, 12 is the x, and 6 is the y. Now I didn't do a great job, but you guys can connect this with a straight line. Yes, it does go through the origin. It is a straight line. So what is the relationship between the x and the y? Remember, we do y over x. Our y is, our x is 2, and our y is 1. So that means that if we do y equals 2x. So this is what we are talking about when we talk about graphing and finding proportional relationships on a graph. All you have to do is look and see, is it a straight line? Does it go through the origin? Yes, yes, that is a proportional relationship. All right, determine if the following equations show a proportional relationship. Here's how you do that. You just put a 0 in for x. If your y equals 0, then it is a proportional relationship because it goes through the origin. If the x is 0, then the y is 0. If the y is any other value except for 0, it is not a proportional relationship. So let's try it out. So we have y equals 3x minus 1. Let's just put in a 0 for x. So 3 times 0 minus 1. What do we get? 3 times 0 is 0 minus 1. Y equals negative 1. This is not proportional because y has to equal 0. Let's try it here. All right, if I put in a 0 for x, 10 times 0, 10 times 0 is 0, y equals 0. Yes, this is a proportional relationship. That's all you got to do, guys. To discover if these things are proportional, it's crazy, stupid, easy. Does the graph show a straight line that goes through the origin? If you put 0 in for x, does y equal 0? All right, so let's see here. Let's talk about tables. All right, so if there are 12 students per teacher, that means for each one teacher in success hour, there are 12 students. So if it's just me, I have 12 kids in my class. If it's me and Mr. Stevens, total, there's 24 kids we are teaching. If it's me and Mr. Stevens and Mr. Cook, total, that would be 36 students we are teaching. If it's me and Mr. Stevens and Mr. Cook and Mr. Devitt, there's 4 teachers, 48 students we are teaching. Is the number of students proportional to the number of teachers? So 1 times 2. Guys, this is all we've been doing for like ever. 12 times 2. 1 times 3 is 3. 12 times 3 is 36. 1 times 4 is 4. 12 times 4 is 48. Yes. Yes, this is proportional. All right, let's look at this one now. The city pool costs $8 per day to visit during the summer. There is also a $25 yearly registration fee. So, is the total cost proportional to the total number of days visited? So on day 1, I've got to pay that yearly fee and $8. So on day 1, I'm paying $33. On day 2, I'm paying $33 plus $8, which is $41. On day 3, I'm paying $49. On day 4, I'm paying $57. So 1 times 2 is 2. 33 times 2 is 66. So this is not a proportional relationship because if I do something to the top, it doesn't get the same result on the bottom. 1 times 3 is 3. 33 times 3 is 99, not 49. This is not proportional. Okay? Looking for those equivalent ratios. You're looking for those equivalent fractions and equivalent ratios. So, we can also make equations to describe each situation. I did this a little bit earlier in the video. If a situation is proportional, you will use your constant ratio in your equation. Make sure you are defining your variables. So we're just going to go over this kind of quickly. We're going to work more on this after spring break. You won't have a ton of questions about this on your quiz. You should also kind of sort of know how to do this sort of stuff from Mr. Cook's room. Sal's Pizzeria sells large pizzas for $11 but charges a $2 delivery fee per order. So let's write an equation to fit this situation. So we're going to say that Mad Eye Moody saying hi. Hi, bud. Hi, bud. All right. So we're going to say Y is the total. The total money paid. This is where we have to define our variables. X is the number of pizzas. All right, so if I buy, let's see here. So if I buy X pizzas, each pizza costs $11. So I can do 11X. because every time I buy a pizza, I have to pay $11. That's a multiplication problem. Equals y. But that's not all I'm paying for. I'm also paying for every order a $2 delivery fee. The $2 delivery fee does not matter how many pizzas I buy. I still pay an extra $2. So I could buy 100 pizzas and I'd only pay a $2 delivery fee. So I don't need to multiply this 2 by anything. I just tack it on at the end as a plus 2. So let's see if this is a proportional relationship real quick. Remember, when I have an equation, all I got to do is stick in a 0. So if I do 11 times 0 plus 2, do I get 0 for my y? 11 times 0 is 0 plus 2. Y is equal to 2. This is not proportional. But what you're really looking for here, all that I was really asking you to do here, is to be able to come up with this equation from the word problem. Okay? All right, guys. Well, thank you for being patient and taking diligent notes. Remember, if you save these notes, including if you save them in the class drawer, in the color drawers by my desk, you can use these notes and any other notes you've taken in my class, this unit, on your quiz. Your quiz will start, I believe, Wednesday for Hendrix, I think, and then it will go, everyone else will have it on Thursday of this week, because next week we will be taking a benchmark test in my classroom and we won't have a chance to finish a quiz. All right, have a great day. I have tasks for you to complete.